For the best viewing experience, please rotate your phone to landscape mode. If you are watching on YouTube, simply tap the full screen icon in the bottom corner. Let's get started. Alright, so let's look at paper chromatography. Now, what does a paper chromatography separate? Now, it separates a mixture of dissolved substances, most often colored inks, dyes, or food colorings. Now, picture this: a race for colors. Put a dot black marker pen on a damp paper, and it will unpack itself perhaps into red, blue, and yellow, or all kinds of colors, each running at its own speed. All right, so we'll get to explain why that happens. Now, some of the key ways that you must take into account: a chromatogram, the finished paper showing the separated spots, is known as a chromatogram. Solvent in front, the furthest point reached by the solvent up the paper. Now, for instance, what we have here is the solvent. The solvent can be absorbed by a particular type of filter paper or a particular paper that absorbs the solvent. Okay, so you can see that there is a faint this paper has absorbed water or has absorbed the solvent. You can see that there is a faint boundary over here. Now, the final distance at which the solvent arrives or reaches, in fact, is known as the solvent front. Solvent, the liquid that carries the dyes up the paper. Now, the dyes are normally placed above the solvent so that the dyes will not sink into the solvent, something that will be elaborated on the next page. Now, we have these steps written for your revision and also so that you can see the step-by-step guide. Now, what you have here is we do have the solvent here, as earlier mentioned. This will be our solvent. Now, a pencil line is drawn above the solvent. All right. So, number one, draw a straight line in pencil, and it's written in bold for emphasis, about 1 centimeter from the bottom of the paper, provided that the pencil line will not sink in the solvent. Pencil is used because ink would dissolve and run with the solvent. So one of the key areas that examiners will ask is, why is a pencil used instead of a pen or ink? And because ink is also a substance that is its own dyes. So normally pencil is used because ink, unlike pencil, will dissolve in the solvent. Number two, place a small concentrated dot of the mixture on the pencil line and let it dry. And obviously this is before this paper is immersed in the solvent. Number three, stand the paper in a tank holding a shallow depth of the solvent. So you can see that the solvent is here at a shallow depth. Now, the solvent must be below the pencil line. The reason why this solvent must be below this pencil line is that the dot any dots or the dot itself, if there is one or if there are several, will end up just dissolving and floating in the solvent. So hence the dots, the solvent must be below the pencil line, or the spot will simply wash off into the solvent. Number four, cover the tank with a lid. So here I've put up a lid here with my red pen. So we have a lid here. So cover the tank with the lid so the solvent does not evaporate from the paper, because obviously the solvent, especially if it's a type of alcohol, it is volatile. So you'd want to avoid any room temperature or outside temperature from making it evaporate before it reaches its final destination, known as the solvent front. Number five, the solvent creeps up the paper. As you can see, the solvent will begin to creep up the paper, and you'll find out that it will reach a final distance that it will stop. The most soluble dyes will travel furthest, whereas the least soluble dyes will travel the least distance. Remove the paper before the solvent reaches the top. Immediately mark the solvent front in pencil and leave it to dry. So you can see that this black dot had red, green, and yellow. Right. So as a result, the three stages of a run, one black spot separates into 3 dyes. So this black spot has separated into 3 dyes, and that is what paper chromatography does. And here is our chromatogram. And if you can recall what chromatogram means, a chromatogram is a finished paper showing the separated spots. All right, now let's have a look at reading a chromatogram, which is one of the crucial aspects of an exam. Now, to identify an unknown mixture, run it alongside reference dyes on the same paper in the same solvent at the same time, of course. A dye in the unknown is identified when its spots sits exactly at the same height as a reference spot. Now, this is an unknown dye X, this one. Now, they are saying unknown dye X contains dyes A, B, and D. It does not contain C. And here is why. You will find out that this was the unknown dye X, but these were reference dyes red, blue, green, and yellow. Now, substances of the same material will have the same solubility. So we could clearly see that this unknown dye has red. Why? Because it traveled the same distance as this red, and also the colors may likely be the same if they're visible. And it also had blue because blue spots emerged from the unknown dye X and traveled the same distance, and likewise with yellow. All right. So what does this picture tell you? The number of spots, number of substances, obviously equal to number of spots equal to number of substances. One spot means a pure substance. So you can see each of these dyes perhaps were pure substances, right? And then this one had a mixture. Now, a spot that lines up with a reference spot is the same dye. So this spot lined up with this one, and hence the same dye. A dye that travels further is more soluble in the solvent. So we can clearly see that yellow traveled further and is more soluble, and the one that travels least, which is red, is least soluble. Colorless spots are made visible with a locating agent or ultraviolet light. All right. Now we also get to look at why purity is tested this way. For example, food colorings and medicines are checked by chromatography. A pure substance leaves one spot only, so any extra spot may be regarded or considered as an impurity. So next up, I think for those who may be doing extended, and probably will be getting to look at calculating the RF value, and especially those who do pure sciences. Should you be interested in signing up for online or face-to-face classes, give me a heads up or message me on +263 777 992 527. All right, and then we can arrange and give you all the details necessary for you to sign up for face-to-face classes and online classes. Please be sure to like, share, and subscribe for more video updates. Thank you for watching.